later I'm going to introduce to you when you area for this, we just can use this one to find out the whole surface. We're going to use this one. Okay, now later I'm going to combine this combination, but this is a straightforward, no issue here. Okay, no issue. But you use this one, then you end up calculating for the circle one. If you made it, this is a circle, imagine this is a kind of circle, then you end up doing this same thing here. Okay, but later we will see how we can derive to this state. Okay, but now I will introduce to you many possible okay, I cannot move too much. Okay, many different position here, therefore you need to be very careful to define this one. Okay, the surface. Okay, one of the concept that I wanted to introduce to you, I'm just draw. Okay, here, okay, imagine this is a dz. Okay, dz. Okay, the first, let's say this is a one quadrant. Okay, here, can you imagine that the surface of this, the first portion, okay, it could be further, okay, let's say, can I take a portion here? Just I take it a few portion here. Okay, can I take this portion? Okay, this portion, roughly. This is what I am calling this as a dz. Okay, dz. Okay, now similarly, the dz portion I just draw here. Okay. Okay, this surface. Okay, this surface also we can be defined as dA. Okay, as a r d theta dz. Okay, I hope that you can see that. Okay, what about this below here? This one. Okay, here. Quadrant. Okay, can you see that? This quadrant is same, but it's changing. Can you see that? This is r d theta dz, right? But what about this quadrant here? This one, the small angle of what do you call the cylindrical? This things is not a complete one, right? Okay, this one is a gate. Can I use r d theta here? Okay, this one, of course you will say yes, I can see r d theta, but come on, you see that small is moving inside, right? Moving inside, therefore we call this as a dr. It's not a dz. Okay, I'm taking portion by portion. Okay, I just chop it off here. You can see this portion alone. If you can read this, okay, wow, this is something kind of straight, and this portion is here. Imagine r d theta, and this is a dr. Therefore, I can calculate, you see, the area. Now only I'm teaching you why are we getting this? Why are we getting these results? Later, you will find out this is something similar to the dA for this will be defined as r d theta dr. Okay. Now you see how many formula differences? Slightly it's a differ. Okay, dA same, but when you looking at the surface of the rectangle of this one, okay, we use r d theta dz, but when we use the small kind of what you call circle, okay, with a certain angle, but okay, is a polar model, right? It's a polar model which it will produce r theta dr. Okay, dr. You can see this is a different. Therefore, you can see this formula. Okay, you can see this formula. Okay, now if the same, you apply for the complete one, you no need to worry about that. Okay, it's automatically become pi. Okay, it's automatically become pi, 2 pi. Okay, if it is a 360 degree, therefore but 180, then all these things later we'll get back to this one. Okay, with this I hope that you got it, the logics that I am trying to say. Okay, 3 concept. Okay, very important. Now we move on for the spherical. Okay, we move on for the spherical. Okay, it will take, see how long it will taking, just to define the simple things. Okay, very simple one. They will say, wow. Okay, it's not as simple as you can imagine. Okay, therefore all this, without this, all this kind of understanding, I'll tell you, it's impossible for some students to really grasp the whole idea, understanding, wow, why like that. Okay, textbooks normally they won't go into this detail. They just quickly they will introduce the formula. Therefore you also won't know why suddenly this formula, why this formula. Okay, but now let me put it to you again. For the spherical, number 3, right? Number 3, for the spherical actual, the logic that we are trying to establish here is again the challenge begin. Okay, I don't know how many of you already master the spherical part of that. That's why I'm putting that you need to do good revision. If you don't revise, then it's a problem. Okay, and I started with all these things, very simple logics. I already simplified the whole thing. I used here phi. Okay, no problem for this. This is, I call it, this is a row. Okay, and when this row falling onto the horizontal state, we call it that as a theta. Okay, theta. And I call this, okay, imaginary kind of things which is coming from here, and it fault on this. Okay, this is, we call it as, I call it r. Okay, because easier, but rho is a sine phi. Okay, now you know the definition of this. I'm not going to define this again and again. Please refer if you don't understand, better you refer to my the lecture, call it triple integral for the spherical. Okay, I did explain I did elaborate to you very in detail. Okay, come back to this one again. Okay, come back to this one. Okay, if this is the scenario here for the horizontal, okay, horizontal I'm talking about, the first thing here, d theta, remember d theta refer to the horizontal. This is a horizontal. Okay, horizontal. Okay, now in horizontal, how do we define this here? Okay, this is a r theta, again same, right? This is kind of, imagine kind of r, okay, d theta, but this is equal to, r is equal to rho sine phi d theta. Okay, hopefully you can see that. Okay, this is very much connected to this. Okay, done? Not yet. Okay, we are going to explore more into detail. Okay, so far I hope that I want you to digest this carefully. Okay, again, I don't know, because when I start, I still recollect my face-to-face teaching. Many students, they will say, sir, could you repeat this work again? Okay, many time I used to see this kind of environment, and they will call me and say, sir, I don't understand what you are trying to say here. Okay, I already explained to you several times. Okay, this one, okay, we are referring the same, this and this is the same. Okay, if this is a theta and this one is a, okay, rho cos phi, right? You agree with me? This is what we call as a z. Okay, earlier to collect back. Okay, what about this? Okay, this one is, okay, this is what I'm going to call r. This r, this r here, this one is a sine, a rho, okay, sine phi. Okay, this one can understood. Now we are bringing this down. Okay, just bring it down here, then you will get a what do you call the r. Okay, then rest of the things similar to the cylindrical, okay, cylindrical method that we are using now. Okay, now let me, please follow carefully, please follow carefully. I'm going to introduce to you again. Slightly I'm going to change some of the concept that you already learned. Okay, because this one is not complete yet, because this is horizontal. Okay, now I use the same logic here. Okay, it's a one step further. Okay, same d theta. We know this is r is actually is a rho sine phi. Okay, I hope that you can see that. Any doubt? No, right? What about this? Okay, this one is r d theta. Okay, now I can say r means is here. I am not going to use r again. I'm going to use this straight away. Okay, sine phi d theta. Is it clear? Okay, clear. Now if I pulled up, okay, this is the state I want you to see. Okay, this portion. What is the portion? Surface. The surface of this spherical. Okay, what is this? This surface. Okay, this one. Okay, I did explain to you. Okay, those cannot see. Sir, I cannot see what you are trying to say here. Okay, imagine there is a, okay, this one. Okay, so far you can understand this is theta, right? Now we are trying to looking at this hemispherical here. Okay, can you imagine that I'm picking this portion here? Okay, this portion here. How to define this? This is theta. This is overall is moving around here horizontally, the theta. Now we are going for vertical. When we go up vertical, okay, the vertical definition is, now we still, this is a rho we are using. And what about this? This is a phi. Can you see that? D phi. That means this one is a rho to d phi. Can you see that? Agree with me? Okay, can or not? Okay, therefore this one is phi d rho d phi. Okay, is it okay? So far clear? I hope that you can follow. Okay, now with that, let me proceed. Okay, with that, I sketch again. I sketch what I have done here. This portion again. Okay, a little bit. Okay, this one here. This is actually, we are referring to not vertical anymore. It's a phi. We are referring to the phi. Okay, some student may come back and argue, sir, you say to this side, what about this? Okay, don't worry about that for the moment. You imagine we are coming from this side or whatever. Okay, arrow is important here, but the value of angle is important here. We are looking at this portion. Okay, is a if if this is the case, imagine this is a row. Okay, if I ask you to find out this, can you find out? Yes, you will say very easy. If this is a d5, this top on this is a row d5. Okay, you can tell about that, right? Okay, now can we combine this whole thing here to find out the surface here and this? Now you get a new formula for that. Can I write that first here? Is easier. dA equals to rho sine phi d theta. Okay, rho d phi. Okay, that means you get a new formula here, sine, okay, d theta d phi. Okay, one thing missing for the volume. What is that? D rho, right? D rho. But this is surface area. Remember, it's dA, huh? It's not a V. It's not a V. It's not a V. Okay. Now with that, I hope that, okay, I just recollect back again what you learned before. I'm not going to be able to combine all these things yet. I just want you to understand if it is hemispherical, okay, if this is the case, and if it is a row, okay, and we know there is a row is actually going one by one inside, okay, therefore it's a 1, it's a row 2, row 3, okay, is going inside. Therefore, if I combine this, you will get dV, rho 2 sine phi d theta d phi d rho. Can you see the difference there? Okay, for the area, this one is missing, but the rest is there. Okay. Okay, then one more model that I'm trying to say again, if this is a surface, okay, I take a one patch of this here, the surface. This surface can be defined as the area sine phi d theta d phi. Can you okay? Is it fine? Okay. Difference. Can you see the difference or not? Okay. With that, okay, we have done almost very important first portion. Now the most complex one. Okay, the complex one, which is I'm going to introduce to you, is not actual. How to understand that not actual? Okay, shadow surface. Okay, I think curious. Yeah, everyone, I don't know how many of you curious to understand this. Hey, how do we use that? Okay, in vector, the surface area is actually the shadow surface is using a kind of model which is something. Okay, I'm going to use this. You can see some books very elaborative on this. I like certain books for this because they are trying to best their best. Okay, I'll try to put it to you this. Okay, my drawing is sketch. Yeah, my sketch is run ready. It's okay. Imagine, okay lah, sorry, this portion is something surface. Okay, okay, it's like slightly not good here. It's look like some bended kind of things, but okay, anyway, whatever, the issue is not related to this side. Actually, it's on the top that I'm going to refer. This one is, imagine, is a surface is smooth. I call this surface here not normal. I'm going to use rho. Okay, this is a dA. Okay, this is a dA, and I call it, this is a rho, but it's a normal. Okay, the rho is normal. Okay, you may say, why, sir, you suddenly say normal, why you don't want to use n? Okay, I don't know, because some references, most of the books, they're using this kind of convention I'm following. Okay, you can use different symbols. For example, you can use, this is a m, for example. Okay, m, whatever. I can use even alpha. Okay, no problem with that. Okay, but what about this? This surface is slightly bit, these things, but rho is a straight, right? Is the original reference to that is a rho, right? Okay, and this is dA is actual reference that we are referring to, actual surface. Imagine this is the actual surface of that. It's not actual anyway, I'll tell you why. Okay, it's not actual, but this is what actually we're going to use to measure this. Okay, this is a dr. The dr is a region. Okay, dr is a region here. Okay, the end, now only I think you may get why you are trying to see this end is a normal unit, and now you can see the angle. Now you got the logic ready, right? Now you got the logics. Why we study gradient. Okay, gradient, angle. That's why before I define for this portion actually. Okay, but which one is actual here? Suppose this is not actual. I cannot say this is a dA, but I just write first. Okay, the dr is actual. Okay, it's actual surface. But not a smooth surface. Okay, but not a smooth surface. What about dA? dA is a shadow. Imagine like similar to this top, on the top that you are seeing here, the shadow, as I mentioned. Can you see this shadow here? This shadow is, look, on the top there is a flat surface there falling onto this. Okay, then can I measure this surface here? I'm using a shadow. I'm using a shadow to measure the top one, Okay, I can't do anything here. Just I cannot change anything because I'm trying to. I can't avoid this. Okay, this is a shadow. Okay, is a. Can you see that? It's a shadow. It's a shadow surface. It's a shadow surface, or not an actual surface. But what is that? What? Smooth surface, right? Smooth surface. Wow. So far we can understand this. Therefore, what are we trying to do here? We are doing kind of mapping here. Okay, we are doing kind of map. I map to dA. It's a kind of mapping. Okay, mapping the R. I'm mapping on dA. Okay, that's what we call it as a shadow. Okay, at least you got it. The logics that I'm trying to say here is a mapping process. Okay, it's a kind of mapping process whereby we map the dr onto dA. Okay, which is this is actually we are reference points that we are using. dA is a reference point that we are using to measure the dr. Okay, this is a very famous model to calculate, any that very difficult things to, this is very difficult to calculate. For example, can you imagine, I wanted to measure surface of sky. Wow, how to go there, over there to just measure the sky? Can I measure the sky using shadow? Can. I can calculate. Okay, that is something we use this method. Okay, which is a far away, right? Okay, this is how I think beautiful. Okay, our ancestors are so smart, but they didn't use this model, but they use something to their tool. They don't have any technology, but still they can measure many things intelligently. Very intelligent. They are very intelligent, and I really amazed with their intelligent. Okay. Now in this particular case, imagine this. We call this P referred to the straight line on the top. But we are referring the end, whereby we just take the theta here. That reference is, we call it as a n. I'm moving very slow, because this topic is it's not a quick, quickly I can. Oh, sorry, is it correct? No, actually I'm referring to the del f. Okay, is a magnitude. Okay, I'm referring to this one. Therefore, there is another way to also. I'm not going to detail. Some students are very curious to analyze all these logics. At this moment, I don't want to go so detail about this mapping process. How, why, the formula. But sometime we can even use dA. Okay, we can use we can use a dA to be calculated as a dr cos theta. If we know the angle, of theta to the n. Okay, if it is this is a rho. Okay, if this is the rho, and I know the angle of that. Okay, I can use my shadow. Okay, I can use my shadow. I can calculate the actual surface of the actual surface of which is difficult to calculate, which is not a smooth surface anyway. Okay, smooth surface. Can you see this is not a smooth surface? Whatever that, you won't believe the camera is here. Can you see the camera? No, the camera is not a smooth here, but you can see the surface look very smooth. The shadow look very smooth, but the camera is not smooth at all. Okay, but you're going to calculate something similar. Okay, something similar to that. Okay, in this particular case, then we already identified this. Okay, I'm going to introduce to you some logics of this. Some students used to ask me some questions on this, but now at the moment, please, I don't want to go so detailed about this. Okay, but why? Okay, rho, you take it rho and n, the relationship with this n. Okay, what is the relationship with this p and n? Okay, with the theta, then we can see this is a rho, the n magnitude of that. It can be calculated with the cos theta. You agree with me? Then now you got the dr logics of that. The surface is these two, combination of this and this, whereby you will get this and a cos. Okay, we will see something. I'm not going to equate this straight away here. Okay, it's not exactly equal, but I'm introducing all these logics. I leave it to you for you to find out how does this formula coming into the picture. Okay, and the formula that I'm going to introduce to you now, the ds for the small s, which is the surface calculation, can be defined as dA. Okay, dA is here, it's not actual shadow we are referring to. Okay, but it's a smooth, because we just take it as a smooth. Divide with the cos theta. Divide with the cos theta. Or we can use another method to do that. dA and dot product with the rho. Okay, this one, magnitude of that. Okay, same. Okay, cos. Okay, you can understand that. Okay, I bring it down, I will get this. Okay, cos. Okay, what happened to this 2? Okay, I don't want to discuss this too detail about this, but try to imagine how can the cos become this modulus of this. Okay, means when I taking the magnitude of this, okay, I'll get the cos. Okay, now the next stage is you get this one, n, open this n. Okay, when you open this end, we know n is this. Okay, you get this del f dA, okay, del f dot with this. Can you see that? Dot with this. Okay, rho. Wow, too many formula I already introduced to you, you know. Within a very short time, I already introduced to you many formula. Can you notice or not? Okay, I haven't come to the problem yet. I'm just introducing to you systematically the formulas. Later, I'm going to combine everything. Okay, are you ready to see the actual formula of the surface integral? Okay, the rho can be I, can be J, can be K. Why? Here, this depends on what I am referring to. Is it the depend on the Z, I, J, K? Therefore, there is a one of this. It can be any one of this, right? Okay, remember, rho must be smooth surface. It can be a negative I, negative J, negative K, or but it must be something like this, or it can be a negative I, okay, something lah. Okay, but it must be smooth. Okay, remember, rho must refer to the smooth surface. Okay, now within a very short time, can you digest this or not? Okay, I think you need a break already. Oh sir, too much already lah. We find it is too much within a very short time, right? Okay, shall we take a small break? Then we continue to the formula for the surface integral. I'm going to introduce to you the combination of all these things into one. Then straight away we start our calculation and etc. Okay, take a break. Okay, go and take a cup of just juice. Okay, I'm vegetarian. Therefore, take a cup of juice and take a, make your mind free. Take a deep breathing. Okay, 2-3 minutes. Okay, take a break. Bye.